This video will discuss practice now 9, questions A, page 22. Okay, now it says that 3 men, okay, can dig 2 identical trenches in 5 hours. Assuming that all the men work at the same rate, how long will it take 5 men to dig 7 such trenches? Okay, so this one is the question. Now, we're dealing with like 3 elements here. Okay, so the one that you can do is you're comparing 2 things separately. Now, you need to compare like one element to the element that is being questioned and the other element to the element that is being questioned. Which one that is being questioned? The hours. Okay, so it means you need to compare men and hours. I will write it here. Men and hours. And then after that, I also will compare trenches and hours. Okay, now if I increase the number of men, like for example, I have a project, okay, and then it says like, oh, 5 men can finish that project for an hour, and I increase it become 7. What do you think about the hours? The hours will be less or will be more? It will be less. Okay, so I would say the hours will go down. How about trenches and hours? I have a project and I will compare it to the hours. If I give you more project, what do you think about the hours? The hours become more or less? It will more, right? So if the trenches is going up, then the hours will also going up. Now, look on the direction of the arrow here. If this one going up, going down. So this one will be inverse. And this one going up, so that one will be direct. Okay, now look on the question. Okay, men, trenches, hours. Now the comparison that I want to do first is the inverse, the men and hours. Okay, so I will write here men, hours. I will leave the trenches there for a while. Okay, the hours is the result of the calculation, right? This is the one that you want to find. So I will put like here is y, and that one will be the x. You still remember about dependent and independent. Okay, on the question it says that 3 men digging 2 trenches will require 5 hours to do it. Right, like that. And then after that I also will write k here, the constant. Okay, when you will dealing with the inverse and direct, we will deal with the k, the constant, and also the notes here. Okay, now we know like men and hours are inverse proportional, or I can say hours is inversely proportional to the men. Now, if we have that kind of statement, then we can find the k, right? Okay, remember this one is the IP, which is that one is inverse proportional. How to find the k? Well, k is equal to x times y. Where then we can find the k, right? Because the x, we know it already, that one is 3. And the y is 5. So that one is equal to 15. In this case, because this one is one question, in one question, it means if I change the men become 1 or become 2 or 5, 7, 8, okay, you need to be sure that when it's multiplied to the hours, the result will be always constant, right? Which is what? It will be 15, 15, 15, 15, 15, right? Even though I change the number of the men, okay, become less or become more than 3, okay, then I need to find the hours. So when I multiply the y with x, the result will be always 15. Remember, constant, the value will be always constant. Now, look on the question here. Okay, the question is what happened if we increase the number of men from 3 to 5, right? So I will make it here 5. Okay, this one is still IP, right? The inverse proportional. And then the k will always 15. Will always be the same, 15. is called as a constant, right? Always the same. Now what will be the hours? Oh, okay. So I will use this formula again. K is equal to yx. What is the K? Okay, 15. What is the y? I don't know. What is the x? 5. So y will be what? 15 divided by 5, which is that one will be 3. Correct? Now look, in here the situation now, the man already matches to the question here. 5. Okay, but the trenches here, okay, I just copied here. I haven't deal with the number of trenches here. It's still 2, right? I haven't done anything with this one, so it's still 2. And then after that, the time here is 3. So I can say that based on the comparison between man hours, which is that one is the inverse proportion, that actually if I hire 5 men digging the identical 2 identical trenches, then it means 3 hours is needed to do those things. Okay, so now the last situation will be 5, 2, and 3, and we're done with this one. Now we do this. The trenches to hours, because we need to change the 2 here becomes 7, so we know like how many hours is needed for 5 men digging 7 identical trenches. Okay, so look here, I will write trenches and hours. Okay, this is the result of the calculation. This one is being asked, right? So I will make it into y and this one into x. What is the last situation here? Is 2 and 3. I will write also k. I will also write nodes. What is the relationship between trenches and hours? Oh, it's a direct proportional. So I can say that y is directly proportional to x. And how to find the k? Well, for the dp or direct proportional, then k is equal to y out of x, which is that one will be 3 out of 2. Now if I change the number of the x here by any number, then you need to be sure the value of y, you need to be sure that when y is being divided by that new number, the result will be 3 out of 2. Okay, now what is the question? The trenches should be what? 7. So I will put 7 here. Okay, the k will be what? Well, stay the same, right? 3 out of 2. What is the correlation between these two things? The y and x is the dp. Now, how to find the y? Well, we can use this formula again. K is equal to y divided by x. What is the k? 3 out of 2. What is the y? I don't know. And then what is the 7? What is the x? Okay, 7. So actually y will be what? 3 out of 2 times 7, which is that one will be equal to 21 out of 2, and that one will be 10.5. So at the end, we can make a conclusion. If the man is 5, I will copy it down here, and then the trans is 7, which is now is the same, both of them, 7. Then the time that is needed here will be what? 10.5 hours. Thank you.